we have to prepare ourselves for the agent age, because in the next year, our website, our mobile app will receive more visit from AI agent than from human being. So in this way, we can have a new way for UI testing that is based on customer journey, no need of code. It's tolerant to UI changes, because if I change a component, a web component on my UI, but customer journey remaining the same, I don't need to rewrite the test. And we have the report that are fully understandable. Hello everyone, I'm Notoriously, and today we are talking about how to develop UI and system testing with LLM. First of all, sorry. Okay, few words about me. I'm a computer engineer, I'm a digital entrepreneur and the CTO of my own company. And I'm the community lead of Google Developer Group Bari, and in addition, I'm a business coach. Andrea?
I'm Andrea. I'm living here, and also a PhD student and at the Polytechnic University of Bari, and also a plant coach. So this is me. So, Mike.
Few words on our company, Wideverse. So we are an innovative SME. We were born in 2016. We are a spin-off of the Polytechnic University of Bari. We are focused on XR and AI technologies in fashion, retail, and manufacturing. Our mission is combine research and creativity to shape the future, promoting a balance between technology, well-being, and human evolution. But now, this is the topic of today. So, how many of you have ever write a test? Okay, cool. How many of you are currently in a QA team? One, only one. Okay, okay. So, just to align all of us, just to recap the pyramid of software testing. From the base, we have unit testing, so we can test each method of our program. Then we have component testing, where we can verify how a single module works. We have integration testing, when we can check how two modules or more than two modules can interact with each other. And then we have system UI testing, where we can check the functionality of the UI and can test the end-to-end of customer journey. So, what is the difference between UI testing and system testing? With UI testing, we are focused on UI. We check the layout. We can check the user interaction with buttons, with input forms, and we check the responsiveness of our website or our mobile app. And then we have system testing that it's focused on end-to-end, and we check the requirements, we check the whole logic of the system, and we check all the customer journey of our application. How we develop system testing nowadays? We can use several frameworks. Now we will see the main ones. The first one is Cypress. Cypress is developer friendly. It has an excellent interactivity for testing and has a great ecosystem and a great community. But we can write tests with Cypress only with JavaScript and TypeScript. it's available only for web, and we have a parallel execution only in cloud. Second one is Selenium. It is more flexible and extensible. We can develop test with several languages. This one is in Kotlin, for instance, and is compatible with a lot of CI/CD pipelines. But we have a steeper learning curve. We have to manually handling all the weight during the process of our test, and is less stable on dynamic UIs. Playwright is developed by Microsoft, is newer than the others, and has a modern architecture, mostly async, that allows to have a fast and reliable execution. But as a smaller community, there are less plugins available. And the last one is Puppeteer, made by Google. It is not think for end-to-end testing, but we have direct access to low-level Chrome capabilities, and it's perfect for crawling, scraping, and activities like this. Okay. All these frameworks have some limits in common. First of all, tests are hard to develop, and they are a time-consuming activity. The development of tests is a human-dependent activity, and we know that our system testing are fragile because the UI is strictly bounded to the test. Let me tell to you a little story. A customer came from us in last February and said, okay, I have my fantastic software, but I don't have a QA team. I would like to implement automated testing. I have the budget for a POC. How can we do? And I talked to Andrea and asked him, how can we do?
And this is my response. I have an AI platform that made all the tests. And here we seen an example of test execution on CRM for creating travel packages. For example, we have owner information in which the user select, in this case, our tool, select all the information for this package and select all the guests and all the information for good travel, I hope. And after all the reservation steps, the system checks that the booking journey is fine and there are all the required information about this. And after this, I think is try to pay, but there is no money on the card.
So, how did we do that? So, we have think, okay, with LLM, we can understand natural language. AI agent can automate web browsing. So, can we use these technologies to perform system testing?
But, there are several tools or framework for make this. Peter, before us, let's make some spoiler about this. So let's talk about Anthropic computer use tool. This tool is based on Anthropic cloud model and is designed to automate desktop activities, so also browser activities, It's offer an API for developers, making it possible to integrate advanced AI-driven automation in various workflows. One of the key features is the ability to work with complex user interfaces by using a virtual machine. And however, there are some challenges. For instance, anthropic computer use tends to be slower compared to more traditional automatic framework. This is mainly because it relies heavily on language model reasoning for every step, which can add latency. And but on the positive side, it's opened a new dimension of new kind of testing. Another tool is OpenAI Operator. It's designed to automate interaction with both browser and desktop environments using OpenAI models. The workflow is organized around an observation action cycle. The tool takes a screenshot of the environment, whether it is a browser or desktop, analyze what is visible, and then decide what action to take next. This could by clicking a button, entering a text, or scrolling a page. After performing the action, it observes the results and plans the next step, repeating the cycle until the task is complete. However, as the anthropic solution, there are still some challenges. The process can be slow, and there is also a learning curve to addressing prompts and workflow to get the target. Another interesting tool is Maestro. Maestro is a testing framework that is mobile first, meaning specifically designed for automate the test and test mobile application. One of the Maestro's features is the entire workflow is defined by using YAML files. This make test creation really readable and really easy for users. And other strength of Maestro is the support. It supports for multiple LLMs. You are not locked into a single AI provider like OpenAI or Anthropic, and you can integrate different languages model based on your need or preferences, and is very cool. Another interesting project is Project Miner by Google. It's an experimental initiative that aims to automate UI testing by leveraging their own AI technology. Project Miner is deeply integrated with Chrome browser, Chromium-like browsers, which means it can interact with web application at a very low level. At the moment, Miner is still an experimental phase and not generally available. However, Google has announced that an API will be available soon. And now let's talk about browser use. Browser use is an open source solution designed for automating only browser interaction using LLM agents. Browser use supports several language models, and browser use is agent ready. So this means is designed to work with AI agents right out of the box, enabling automation for complex texting tasks without having scripting or manual intervention. So
looking to our solution, first of all, we have to see the customer requirements. We are talking about a travel booking platform. The customer has a great concern about data privacy, so we cannot run all tests in cloud. He prefer open source tools, of course, and he would like to take under control all the costs. And he would like, in addition, to have a complete report of the test with the explanation of the AI decisions and tasks.
So our journey began with a manual approach, this first iteration of our automated UI testing solution. In this phase, we use Claude Sonnet 3.7 as our main LLM, paired with Anthropic computer use tool. The setup involved running everything inside a virtual machine equipped with a browser, so we could observe and control the environment easily. It worked. The user would manually create a prompt describing the action they wanted to test. The LLM would then interpret this instruction and automate the browser interaction accordingly. And the user manually control and validate, so we could confirm whether the action matches the expected result in real time.
So, in this case, we instead writing a test by code, we are writing the prompt to test the customer journey. It's easy to set up, and we have live results. But we have a lot of problem with this first iteration of development. First of all, we need to know how to create the prompt. We have limited control of the execution. The reporting is still completely manual, and even the task monitoring. We can't run the tests on batch execution, and the execution is really, really, really slow. And last thing is that the available context is small, so we can test only a piece of our software, not a completely an entire customer journey.
So after learning from the limits of our first iteration, we moved on a much more automated approach. The second iteration of our solution. In this phase, we focus on reducing manual work and making the process more scalable. Our early setup with a virtual machine was heavy and not maintainable, so we can shift to a new tool. So we use browser use. Sorry for the word. And browser use allow us to delete the overhead of a virtual machine. In addition, we choose to work with Gemini as our language model for this iteration. The main advance of Gemini was its large context window. This allows our system to process longer and more complex user journey in a single pass, and leading fewer misunderstanding or step omission. Compared with other models, Gemini also provides a better balance of reasoning power and efficiency, which was crucial for processing real-world testing scenarios without constant manual intervention. And instead of relying on handwritten prompts, we introduced the concept of a user journey document, a high-level description of the actions a user should perform during the test, and is how it's worked. The user journey was processed automatically by an extractor and a task refiner. These models read the document, break down the steps, and translate them into an actionable tasks for the LLM agent. The browser use tool then execute those actions on the web interface, following closely the intended user flow. After each test run, the automated report was generated, providing a clear summary of what happened and whether an object or a goal were achieved. And in this second iteration, Mike?
So in this iteration, we don't have human supervision. We don't need to be a prompting expert, and we have a lighter workflow because we don't have the VM using browser use, and then we have a larger context thanks to Gemini. So in this way, we can test an entire customer journey from the beginning to the end. But we have other limits. We still don't have a monitoring system. We have a high interruption rate, and we have an high error rate. So we have a lot of problem with this system that doesn't complete all the tasks.
After experimenting with user journey processing, we moved to our third iteration, which brought a significant increase of robustness and automation intelligence behind. We realized that while automation could execute user journey, it struggled with error and unexpected situations. In real applications, things can go wrong. An element might not load, a page could change, or a step might fail unexpectedly. To solve this, we introduced a more modular agent-based architecture. So agents everywhere. So we have first agent, user journey extractor and refiner. This component break down and generate all the steps. We also already see this. User journey evaluator. This agent analyzes the user journey to understand intent and expected outcomes and perform edits on the extracted user journey. After this, we have the test executor. This agent performs the actual test step in the application. And the test evaluator with the dynamic retry, perhaps the biggest innovation here. This agent monitors each test step. If something fails, say a button it's found or a page doesn't load, it dynamically retries the action, adapting all needed rather than simply aborting the test. This architecture made our system much more resilient and autonomous. Tests could now recover from common issues automatically, reducing the need for human intervention and manual reruns. So why this is important? First of all, high reliability. We drastically reduce false negative caused by temporary glitches or UI delays. We make more agent and the agent make decisions and adapt on the fly, similar sorry, to how a real tester could troubleshoot issues. And the system logs all the actions and decisions, making it easy to review what happened and why. One of the key innovations of our third iteration is dynamic retry. In traditional automating testing, if a step fails, the test usually just stops and reports an error. This can be frustrating, especially for long and complex user journeys, because a small glitch or a delay can invalidate an entire test run. With dynamic retry, our test agents don't immediately give up and when something goes wrong. Instead, they actively try to understand what fails and adapt their strategy to recover and continue the test. For example, if the agent is supposed to select the guide for the tour, but the guide drop-down doesn't appear right away, the agent will wait, refresh, or attempt to reattempt the action. If the user needs to select an all-inclusive package and the UI takes longer to load, the agent doesn't just fail, tries an alternative method to interact with the interface based on the context and the previous experience. And it can try multiple approaches for the same step, learning from what you find in the context. And building on the improvement of our previous iterations, the fourth iteration of our solution took our agent-based architecture even further by adding specialized intelligence and handling complex UI elements. We keep the same pipeline as before, but now we introduce specialized agents, also called expert, designed to handle particularly challenging UI components such as drop-down or modal dialogues. For example, the drop-down expert agent is specialized in detecting opening and selecting values in drop-down menus. Even if the UI change in the time, new drop-down style new drop-down styles are introduced. For the modal expert, the modal expert agent can recognize and interact with pop-up modals and that might otherwise disrupt or block the automation process. Complex UI elements like drop-down or modal are most common source of flakiness in the test, in UI testing. Standard automation scripts often struggle with them, especially when they are timing issues or with custom UI frameworks. And so our system can adapt to different implementation of the same UI concept, handle UI changes more smoothly, and further reduce the need of human intervention or supervision. Let's take a look at how we actually create a new agent for handling a custom field in this case. So If you look at the code snippet in the slide, you will see that defining a new agent in our system is very simple. Each agent is implemented as an extension of a Python class that is based on agent class that give access to more common methods and properties. In the code, you can see an example of an agent called drop-down agent. The agent received the field to be filled with an initial action, which provided directly by the test executor agent. With the run method, the agent applies the current logic and run the test. For example, it can take what type of data are available and apply any needed reasoning about this data. It is a very interesting way to do this. And in our fifth iteration, we continue to evolve our agent-based approach to make UI testing more even flexible and realistic. We maintain all the key components from the previous iterations, and the main innovation of this iteration was the integration of an user-provide input data into our automation process. Now we given user data with specific run our test with specific informations directly using data provided by user. These values, such as name, emails, dates, and so on, are supplied as a part of the testing configuration as a dataset, and the agent use this information when performing an UI iteration. And the test executor is able to coordinate which the input data, ensuring that even complex or dynamical forms are completed accurately according to the provided data. And so this is the final result we already seen. And the final picture.
Yeah, so we use the browser use to automate the website navigation. We use Gemini, to process the customer journey and decide all the tasks that the tool should do. And we use the agent-based architecture inside browser use that allow us to manage the complexity of a web UI with a lot of components like drop-down, input forms, modals, and so on. So in this way, we create a system and UI testing tool. We can process customer journey by the documentation without the need of coding tests. We can run tests in reliable way, and we can log each step and each decision of the LLM with an attached video of the execution. So in this way, the customer can control what happened on the test. So some usability consideration. In this way, we can check the UI standard of our website or our application, because if an agent doesn't understand how to navigate one component, we should have a problem. Same thing for the UX, because if a customer journey is not so clear for an agent, maybe that it can be not clear for a human being. And lastly, but more important one, we have to prepare ourselves for the agent age, because in the next year, our website, our mobile app will receive more visit from AI agent than from human being. So in this way, we can have a new way for UI testing that is based on customer journey, no need of code. It's tolerant to UI changes, because if I change a component, a web component on my UI, but the customer journey remaining the same, I don't need to rewrite the test. And we have the report that are fully understandable. Okay, this is the way to make tests for the future. And of course, we have still some limitation. First of all, using this software are slow. We can't use those software for performance tests at the moment. We can't use those software for usability tests, and of course, we can't use this software for stress test. But
that said, our next steps are clear. We plan to adopt MCP to allow a smarter delegation and best parallelism. We will also explore how to combine this system with traditional frameworks like Selenium using automatic code generation. And this is just the beginning, Mike, right?
yeah, this is the beginning. So writing UI tests can be like writing user stories. Let's start preparing for this future today. Thank you.
All right. Thank you, Michele Antonio, and thank you, Andrea, for the presentation. So we have a question from the online platform. If we have some questions here, raise the hand so that we can reach you with a microphone.